So, ever wondered how those fully addressable LEDs work? Well, for the longest time, so did I. But when I decided to work on a project that I had bouncing around in my head for a while, I decided to go down the rabbit hole and find out how they work, what different kinds there are, and, more importantly, how you control them. First, a word about my project. Unlike now, during the warmer spring, summer, and fall months, we like to spend a great deal of time outside on the deck, underneath a patio umbrella. Except when it gets dark, it's a little tough to see, and so we generally pack it in early and go inside. And I'd always thought, wouldn't it be nice if I had some sort of a lighting system under the umbrella that would allow us to enjoy more time outside? And then I thought, hey, what about some of those fully addressable LED strips? That way I could dial up whatever color I want, even white, and patterns if I so choose. The possibilities were limitless. In fact, I could put one of those LED strips under each of the ribs underneath the umbrella. That would give me lots of light. The configuration should be pretty straightforward. Underneath the umbrella, I simply locate the 8 metal ribs that support the canopy. Then on each of those ribs, I apply an LED strip along its length. When I measured them, each rib was a little over 66 inches long, and that's allowing for some of the material at the end to hook onto the canopy. So we'll have to remember that. Now we got to figure out what lengths of LED strips we can get. Now when you start shopping for these things, you'll notice that there's just tons of different sizes and types and LED counts per meter and all this kind of thing. But the one thing they all have in common is each spool is 5 meters in length. That's critical to know. I opted for the LED strips with 60 LEDs per meter. That seemed about the right size, which means a 5 meter length has a total of 300 LEDs on it. That's a lot. But what happens when we divide that by 3? 100 LEDs. That seems like a reasonable number to work with, but what length do I end up with? As it turns out, 5 meters, when you convert it to inches and divide it by 3, comes out to about 65 inches. Perfect!
How convenient!
But how to control them? Well, the best way to know how to control something is to understand it first. So we're going down the rabbit hole here, folks. Hang on. Let's first take a look at an LED strip to see how it's constructed. This is one of the LED strips. At first glance, you probably can't tell if it's a 3 or 4 color LED. It's just a bunch of little modules stuck on a strip in a row. The easiest way to tell which is by the number when you order one of these. Most LED strips are identified as either a WS2812B or an SK6812 type. These two numbers actually refer to the protocol they use to communicate, and the protocol you use is very important. At a quick glance, they will be almost identical, but there are some telltale signs that can let you know what you're dealing with if you look closely enough. If you see one that looks like this, it's likely a WS2812B type of LED. These are the 3 color LEDs. And while the LEDs inside don't actually have a color, I've marked the LEDs in this markup. If you look closely, you'll see the 3 individual R, G, and B LEDs, plus the little controller chip that is the heart of how these clever little modules work. On the other hand, if you see one like this, that extra off-white bit is the white LED, so this is probably an SK6812 type. Now keep in mind there are other types out there, but these two are the most common and the de facto standard for most DIY projects. They still have the little controller chip. Now let's see how we send the data to them. To simplify things, I'm going to create a little box. This box will contain the block of data used to tell each LED module what to do. What that data looks like, I'll cover in a moment. But for now, let's just say every box contains enough LED data. If we take one of the LEDs and put, say, 10 of them in a line on a strip, I can use the data line to send the data down it like boxes on a conveyor belt. As each box arrives, each LED takes the next box that arrives and removes it, so it hangs onto that data. The next box moves on to the next LED, and so on. Eventually the last box gets to the last LED. At this point, every LED has got its own box or block of data. In this way, each LED can get a unique instruction, which is how they are individually addressable. Now this diagram isn't 100% accurate because as the data comes in, it actually goes in just to the first LED. Then once it grabs its data, it passes everything else on through to the next one. So that first LED actually sees every piece of data that goes in. So then how does it know when it's its turn to take another chunk of data? Simple. When the data stops. At some point after the pulses stop, it realizes, oh, nothing else is coming in. So when there's a break in the action, the next time I see some data, we must be starting over again. Next, you need to understand how all those different colors get created. As it turns out, each red, green, and blue LED can have 256 different brightness levels, ranging from off to full brightness. That little controller chip looks after this by using a value from 0 to 255 and uses that as the brightness value for each color LED in the module. By combining different brightness values for each LED, you can create any color you want. 16,777,216 colors, to be exact. As it turns out, 255 is the largest number you can represent with 8 bits of data. Since there are 3 LEDs, we need 3 times that, or 24 bits for each LED module. Now if we're using the 4-color LEDs, we'll also need 8 bits of data for the white LED too, so we need 32 bits of data in total. As you can see, this means we must be very careful about the amount of data we send to them. In our previous example with the boxes, each of the boxes must contain either 24 or 32 bits of data. When I said we had to be careful with the data, I wasn't kidding. The trickiest part is the timing of those little pulses we send down the wire. They're sent at a rate of 800 kilohertz or 800,000 pulses per second. So how do we tell the difference between a 1 and a 0? It's the pulse width. To send a 0, we first set the pulse high for 0.4 of a microsecond. Then we drop it low for 0.85 microseconds. If we want to send a 1, we send it high for 0.8 microseconds and low for 0.45 microseconds. So for the full 32 bits that I'd like to send per each LED module, I need a total of 40 microseconds. That's pretty fast. For my project, each LED strip will have 100 LEDs, so I'll need a total of 4 milliseconds to update the entire strip. To put it in perspective, I could, in theory, update the entire strip of LEDs 250 times a second. The video you are watching runs at only 30 frames per second. But wait, I hear you cry. You said you were going to use 8 LED strips, not just 1. Yeah, good catch. So I have to divide that number by 8. So really, I could update the entire thing at 31.25 times per second. That's still slightly faster than video. I decided to go with the 4-color LEDs because I wanted that sort of softer, warm white rather than that harsh white you get when you just mix red, green, and blue. But now, I said in theory I could control them pretty fast. And that brings us to what kind of controller should I use? Most hobbyists will agree that probably the 2 most popular are these, an Arduino and an ESP32. Now they both have their pros and cons. The Arduino, very popular, tons of different I/O pins on it, including some specialized ones for doing things like monitoring analog voltages and outputting pulse width modulation or PWM signals for controlling servos quite easily, that sort of thing. I didn't need any of those, but they're easy to get, they're cheap. Then there's the ESP32, a little bit bigger, but on the plus side, it has built-in Wi-Fi and Bluetooth, and I thought that would probably be more useful than some of the specialized I/O pins that the Arduino offered. No pulse width modulation, no analog voltages, but I really didn't need any of those. And as it turns out, you can still use the Arduino IDE editor to write and compile all of your code, so that the learning curve is not very steep. I'd worked with Arduinos before, so programming one of these was fairly straightforward. The one downside with these ESP32s
is the I/O pins work at a 3.3 volt logic level, not 5 volts, which is what the LED strips are looking for. However, there's a fix for that. One of these little guys. It's called a level converter, and this tiny little thing actually provides 8 inputs and 8 outputs, perfect for what I was doing, in a tiny little board like this. They're cheap, easy to get, easy to hook up, so although it does introduce a second component to the whole system, at the end of the day, it's what I wanted to use with the ESP32.
Now, I talked about all the timing and the difficulty you'd have trying to get the pulses just right, setting them down the wire, and coding that would be terribly difficult. Fortunately, you don't have to. Clever people have provided libraries that you can use that handle all the heavy lifting for that kind of thing. There are 2 main types that you can choose from when working with these LED strips: Fast LED and Adafruit NeoPixel. Both are very well written pieces of code. However, there is one thing that you should take into consideration. If you are using the 4-color LEDs with the white options, Fast LED does not support those types of LED strips. Fortunately, the Adafruit NeoPixel library does. So if you're going to go with the 4-color LEDs yourself, Adafruit NeoPixel is the one to go with.
Now, there's an interesting little quirk with the ESP32s. As it turns out, not all I/O pins are created equal. As a matter of fact, some of them are tied to internal functions, and so they may not have the bandwidth that you need to control the LED strips as accurately as you'd like. Fortunately, with a little research, I found out that there are definitely 8 that work absolutely perfectly, and I'll give those to you now.
8 pins that are guaranteed to work for you are 18, 19, 21, 23, 25, 27, 32, and 33. I can guarantee you these work perfectly.
Also, whether you decide to go with the ESP32 or an Arduino, and so you may or may not end up using one of these level converters, there is one extra little tip I'd like to pass on. It's recommended that you actually insert a 330 ohm resistor between the output pin and the input to your LED strips. I found this documented on numerous occasions, and I tried it out and it seems to work flawlessly. So don't forget to do that too.
These resistors are used simply to help condition the digital signal lines, so there's not a lot of power going through them. So you can either use individual 330 ohm quarter watt resistors, or I happened to get lucky and I found a dip package with 8 resistors in a single package that I could use. That made it a little bit smaller, so that was nice.
The last thing I want to talk about is the power supply. Although LEDs by themselves don't individually consume a lot of power, when you get 800 of them hooked up, yeah, the current's going to add up. So I ended up ordering a 5 volt, 10 amp power supply. If you start doing the math, even that seems like it's underpowered, but so far it hasn't let me down. So keep that in mind. I'm not going to delve right into the code. There's too much of it, and we'd be here for weeks. However, I will say this, with some careful planning, a lot of experimentation, and quite a bit of fun, you'll be able to come up with some pretty neat looking effects with a bunch of LED strips. Take a look at what I got.
A cool rainbow effect, with the colors slowly transitioning across all 8 LED strips. A nifty shooting star effect. The rate at which they appear and how fast they move across is completely adjustable. You'll notice that the tail is actually programmed. It's not a leftover from the video or your eyes. The tail is actually made up of 3 different colors. A nice multicolored stripe effect, where you can select between either 2 or 3 different colors and have between 1 to 5 repetitions of the stripe pattern. A fully configurable gradient pattern, where you can have the gradient either transition directly across all the strips at once or have it flow downwards across the strips. Fully programmable. And thanks to the built-in Wi-Fi capability, my controller actually produces its own little web interface, which is how you control everything. Hopefully that'll give you some idea of some of the things you should be able to do with a controller and a set of LED strips. There's lots of capability in there, so why don't you go try some yourself and have fun? Thanks for watching, and I hope you learned something.